Welcome to AI Frontiers, your guide to the cutting-edge world of artificial intelligence and computer vision. Today we're exploring a revolution happening right now in machine vision systems. We'll dive into 16 groundbreaking papers that are reshaping how machines see and understand our world, from coral conservation to security intelligence. These aren't future concepts. They're real breakthroughs being deployed today across medical diagnosis, environmental monitoring, and beyond. Picture this: a machine that can look at a single photograph of coral and tell you not just what species it is, but exactly how much living tissue remains after a bleaching event, down to the cubic centimeter. Or imagine an AI system that can watch security footage and instantly flag truly unusual behavior, not just someone running, but someone running in a context where running doesn't belong. These scenarios represent a surprising reality check about what computer vision can accomplish today. While humans might miss subtle details or get tired after hours of monitoring, AI systems process 30 frames per second, 24 hours a day, 7 days a week, consistently catching details that human observers overlook. These aren't science fiction concepts anymore. They're actively deployed systems making real-world impact. Understanding why computer vision matters now requires recognizing the limitations of traditional systems. Conventional vision technologies required perfect conditions to function properly, controlled lighting, clear backgrounds, and predictable scenarios. But the real world is inherently messy, with constantly changing lighting conditions, objects blocking the view, and environmental noise interfering with sensors. The new generation of AI-powered vision systems handles this complexity much like humans do, adapting to changing conditions and understanding contexts. These applications have become critical for addressing climate change, improving healthcare access, and enhancing public safety. Today's cutting-edge research in university labs becomes tomorrow's standard tools deployed across industries worldwide. To understand computer vision, imagine teaching a child to recognize faces. The process starts with basic concepts, identifying simple shapes, distinguishing colors, and recognizing patterns. Gradually, the system builds up to more complex scene understanding, learning to identify objects, understand their relationships, and predict what might happen next. The crucial advancement comes with adding context awareness, understanding not just what objects are present, but whether they belong in a particular setting. The result is artificial intelligence that sees meaning, rather than just processing pixels, creating systems that can make sophisticated judgments about visual information, much like human experts would. Our first major theme focuses on precision environmental monitoring, where AI provides unprecedented tools for understanding nature's health. Modern systems can assess coral bleaching with millimeter-level accuracy, analyze forest canopy structures for biodiversity mapping, and detect ocean plastic pollution from satellite imagery, spanning thousands of square kilometers. Think of it as having a microscope that works at planetary scale. The same precision instruments that examine tiny biological samples can now monitor entire ecosystems. Environmental scientists gain measurement tools that were previously impossible, enabling real-time monitoring of climate change impacts and biodiversity loss across global scales. The second theme explores context-aware security systems that go far beyond simple motion detection. These AI systems understand the difference between normal and suspicious behavior by considering location, time of day, and social contexts. Rather than triggering alarms every time someone runs, they evaluate whether running makes sense in that particular situation. Real-world deployments have reduced false alarms by 90%, eliminating the thousands of unnecessary alerts that plague traditional security systems. It's like having a security guard who never gets tired, never loses focus, and maintains perfect attention to detail around the clock. Importantly, these systems preserve privacy by analyzing behavior patterns without storing or identifying individual faces. Medical imaging represents our third breakthrough theme, where AI achieves human expert-level diagnostic performance. Systems can now detect skin cancer from smartphone photographs, screen for retinal diseases in remote areas lacking specialists, and provide real-time surgical guidance during complex procedures. This technology functions like having a medical specialist available 24 hours a day, anywhere in the world. The impact extends far beyond convenience. It democratizes expert medical knowledge globally, bringing world-class diagnostic capabilities to underserved communities and remote locations where specialist physicians are unavailable. The key findings from recent research reveal remarkable achievements across all application areas. One research team achieved 99.2% accuracy in coral species identification, while security AI systems reduced false positives from 1,000 daily alerts to just 50. Medical AI matched experienced dermatologist performance across 10,000 test cases, and environmental monitoring systems now operate effectively at ecosystem scale, rather than individual sample points. The game-changing factor across all these applications proved to be context awareness, the ability to understand not just what the system sees, but what that visual information means in its specific situation. Today's featured paper comes from Chen and colleagues, presenting revolutionary coral conservation AI that represents the first system capable of measuring coral tissue loss volumetrically. This breakthrough technology combines underwater photography with three-dimensional reconstruction techniques to achieve cubic centimeter precision, even in challenging field conditions. The system has been deployed across 15 reef systems globally, enabling marine biologists to implement real-time bleaching response strategies. Rather than waiting weeks for laboratory analysis of collected samples, researchers can now assess coral health immediately and take protective action before damage becomes irreversible. The technical implementation behind this coral monitoring system demonstrates sophisticated engineering solutions. Multispectral imaging captures invisible coral stress indicators that human eyes cannot detect, while neural networks trained on 100,000 coral samples provide species identification and health assessment. Three-dimensional point clouds measure tissue thickness changes with millimeter precision, and edge computing enables real-time analysis directly underwater without requiring surface communication. Results are uploaded through specialized underwater communication networks, providing immediate data to research stations and conservation organizations worldwide. The real-world impact of this coral conservation technology extends far beyond academic research. Early bleaching detection enables intervention before coral colonies suffer permanent damage, while precise damage assessment guides restoration efforts toward the most critical areas. The cost per survey has dropped dramatically from $10,000 to $500, allowing marine biologists to monitor 10 times more reef systems with the same budget. Data quality has improved significantly by eliminating human measurement errors that previously introduced inconsistencies in long-term monitoring datasets. Looking toward future directions in computer vision, several emerging trends promise even greater capabilities. Multimodal fusion combines visual information with other sensors, like audio, temperature, and chemical detection to create more comprehensive understanding. Real-time processing is moving from cloud-based systems to edge computing, reducing latency and enabling operation in remote locations without internet connectivity. Explainable AI helps humans understand how systems reach their decisions, building trust and enabling better collaboration between human experts and artificial intelligence. Cross-domain transfer learning accelerates development by applying knowledge gained in one field to solve problems in completely different areas. These democratized tools are making expert-level capabilities globally accessible. In conclusion, we've witnessed computer vision evolve from simple object detection to sophisticated understanding of complex visual scenes. Real-world deployment across environmental monitoring, security systems, and medical diagnosis proves the tangible impact of academic research. Context awareness has emerged as the key factor separating today's AI systems from previous generations of computer vision technology. Environmental and medical applications are literally saving lives by enabling early intervention and expanding access to expert knowledge. The future belongs to machines that truly see, not just processing pixels, but understanding meaning, context, and implications of visual information. This analysis represents a collaborative effort between artificial intelligence and human expertise. Content was synthesized using Claude Sonnet 4 from the May 14, 2025 model release, with audio generated through DeepGram text-to-speech technology. Visual elements were created using OpenAI's image generation systems, and human expert review ensures accuracy and relevance of all technical content. While every effort has been made to maintain precision, some oversights may exist in this rapidly evolving field. All original research references and archive preprint server links are provided for readers seeking additional technical details. Thank you for joining us on AI Frontiers, where we explore tomorrow's technology today. Subscribe for weekly deep dives into cutting-edge research that's reshaping our world. Join our community of researchers, developers, and innovators who never want to miss breakthrough discoveries in artificial intelligence and computer vision. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.